freak out. I have your 1-7 notes pulled up, and I've got them all filled out, but I'll go over them kind of step by step with you. Again, you watch the video at your speed, so if you're okay with me flying through, then fly through with me. If you need to stop and copy, pause the video and copy. If I say something and you think, I think I need to hear that again, stop, rewind, listen to it again. So we're looking at combinations of functions and compositions of functions. So in most cases, we're going to have two separate functions, like maybe, for example, a quadratic is one of them and a linear is another one. And we're going to do stuff with them. We might add them together. We might subtract them. We might multiply them. We might divide them. So in these examples, you are given two functions. So I went ahead in your notes. I color-coded one of the functions pink, and I color-coded the other function blue. Just so when it shows you what it is to do, I can say, okay, that means we're taking the pink function minus the blue function, or whatever. So in example number 1, it's telling you to add the two functions together. So this means that we're going to add the two functions together, and they still have an x in them. So add them together. I've got the pink function. I need to add that to the blue function, and then simplify if you can. And I think you can collect like terms. This is how you're supposed to write your answer. F plus g of x. And then this is what I get when I simplify. Oh, and I think it threw in there, find the domain. So I looked at my answer. I'm like, you know what? That's a quadratic. I can plug anything into a quadratic. Remember, on domain, there are two things you got to watch out for. You can't divide by 0. You can't square root a negative. So if there's no division or rooting, you're good. Your domain is all real numbers. Number 2. Number 2 is saying take all of f and subtract all of g. So this is what it looks like. Labeled it. Here is all of f. Subtract all of g. Not just the first term, but subtract the whole thing. So I'm going to simplify it. The first thing I'm going to do is distribute my negative. And then collect like terms. And look, I've labeled my answer. Are we good on plugging anything in? Yep. Domain is all real numbers. Number 3. This is saying f times g of x. So it's saying multiply the two functions together. Well, this got fun. So here's a f, a trinomial. Here's g, a binomial. When you multiply a trinomial with a binomial, you get a 6-term polynomial. So what I did, and I usually have to put my fingers on my paper to keep track. So what I'll do is I'll put my finger on x, and I'll make sure I'll take this pink term, this pink term, this pink term times x. So this times x, this times x, this times x. Then I move my finger to the 1, and this times 1, this times 1, this times 1. I got a 1, 2, 3, 4, 5, 6. I got a 6-term polynomial when I distributed all that out. And then I collected like terms, and I got a cubic. And I can plug anything into a cubic. So again, I said my domain was all real numbers. Number 4 is telling us to divide. F goes on top, G goes on the bottom. Here's what it looks like. I just left it like this. And can you plug anything in? Well, you got to be careful here because you do have division going on. So since you don't want to divide by 0, how about you don't allow x to be -1? So this is what it looks like to say my domain is all real numbers except -1. And then if I put that in interval notation, like just a quick review from last chapter, I can go anywhere from -infinity leading all the way up to -1, but don't include -1. And then -1 to positive infinity. And that's what my domain looks like in interval notation. number 5. Number 5 is saying add the two functions, and once you get them added, then plug in -2. Now, I already added the two functions. I added them up here. So keep in mind, I already added the two functions. Here's what they look like added together with an x in them. Right? So I copied that down. That just came straight from up top. And then it's okay, now I'm ready. Now I'm ready to plug in -2. So I'm going to plug in -2 there, and I'm going to plug in -2 there. This is what it looks like when I plug in -2. And I did the math, and that's what I get as my answer. And look how I labeled it. All right, now on this one, this was interesting. This says multiply the two functions, then plug in one, kind of like what I did with addition. But I'm supposed to use the graph below. So don't use the functions up there. Use these new functions. You're like, but wait, I don't have equations to multiply together. No, you don't. So here's another way to do it. You can do, instead of multiplying your functions and then plugging in one, you can go ahead and plug 1 into each function. Plug 1 into f, and see what you get, times, and plug 1 into g. So, ready? Let's look at f. I color-coded them. It's the yellow one. When x is 1, find what y is. So I'm searching, oh, there it is. Y is 3. So when I plug in 1 to f, I get 3. Let's do g. Plug 1 into g. Plug 1 into g. Search for g. Where is it? There it is. What's y? Well, y is -5. So when I plug 1 into g, I get -5 for. When I plug 1 as an x value into g, this is what I get as my y value, and it's saying take this one times this one, and I get f times g is -15. Okay, moving right along. All right. Before I show you composition of functions, I just want to make sure you remember what it looks like to plug in something messy in for x. So we did this back in the first unit. If f of x is this parabola, find f with this substituted in. So what I'm going to do is I'm going to come over here. Everywhere there's an x, basically I'm going to take out the x. Remove it, remove it, remove it. And in its place, I'm going to write x plus 3. X plus h. Remove it, do a rewrite. Remove it, do a rewrite. Remove it, do a rewrite. And then, of course, I would like FOIL and distribute and all that. Just a reminder of what it looks like when you substitute something messy into a function. That's what I'm getting ready to do with you. So, we're doing composition of functions. So when you see composition of functions, you're going to see, it looks like fog. It's f, and it's a tiny circle with a g. What this means is we're going to combine f and g, but we're going to embed one of them in the other one. So g is the function that gets embedded into f. And another way to write it, I like this way better, is we're going to take our entire g of x function and we're going to embed it or substitute it into our f function. Right? Y'all are used to like plugging in 2. Well, now we're going to plug in the entire g of x function. Okay? So again, I've labeled them. What if f looks like this? I color-coded it pink. What if g looks like this? First thing it says is to find f of g of x. So, again, I prefer to write it like this. F composition g means I'm going to take my entire g of x function. Now, this entire function is blue, okay? I've clouded it with blue. Take the entire blue cloud, substitute it into f, the pink one. So take out the x and substitute this mess right there. Here's what it's going to look like. F used to be 5x plus 6. Now it's 5 times g of x, the whole mess, plus 6. Once you have that first line written, everything after that should be easy. You're going to distribute and collect like terms. Distribute, collect like terms. I get just a basic quadratic, so my domain is all real numbers. Okay? Next one says, all right, do the same thing, only backwards. So this time we're doing G composition F. G of F. So this time, G of f of x. I'm going to take all of f, right there, pink cloud. I'm going to take all of f. I'm going to plug it into G everywhere I see an x. So this comes out in its place, pink cloud. This comes out in its place, pink cloud. And that's what it looks like. G used to say 2x squared minus x minus 1. Now it says 2 pink cloud squared minus pink cloud minus 1. FOIL. I'm getting ready to simplify. You've got to FOIL that. So I did. I FOILed it. Binomial times a binomial, first, outer, inner, last. This is what I got. I'm going to distribute my 2. And I'm going to collect like terms. And I get a quadratic. There's no division in there. There's no radical in there. My domain is all real numbers. All right, last one. Let's take f composition G. Let's take f of G. No, wait, we've already done that. We've already found what is f of G of x. We already did that. Oh, here it is. F of G of x is that. So I'm going to take this quadratic, 10x squared minus 5x plus 1. And this one is saying plug negative 1 into that. So plug negative 1 in, plug negative 1 in. That's what I get. All right. On the next set of notes, kind of doing the same thing, just substituting, giving domain. So f of g of x means I'm going to take g of x, the pink cloud, and plug it in to f of x everywhere I see an x. So this comes out, pink cloud goes in its place. That's it, that's my answer. Now for domain, quick review of what we did the last unit. Domain, remember how you can't root a negative. So I'm going to take the contents, x squared minus 9. I'm going to take the contents and say what's underneath my radical has to be, well, it can't be negative. It has to be 0 or positive. It has to be 0 or positive. Okay? Move the 9 over, square root both sides. Don't forget positive, negative. Now, this is what was tricky. When you use the positive root, your symbol stays the same. When you use the negative root, that's when your symbol flips around. I did not write this in interval notation. It didn't say that I had to, so I didn't. Next one. This is saying take f of x, the blue cloud, and bury it into g of x. So I get the quantity radical x minus 9 squared. I went ahead and squared it. It eradicates the radical, and I get x minus 9. It's linear, all real numbers. It's all good. Okay, now, I've shown you how to find compositions of functions. I've talked about taking one entire function and embedding it in another function. I want to tell you something that's going to that might just kind of blow your mind. Take a look at either function. I don't know. I'll do this one. I know that you know when it says find f of 2, you're supposed to plug 2 in for x. So plug 2 in for x, what do you get? I know, 16, but no, like, what is that? What does that represent? When you plug 2 in for x, what do you get out of it? You get a y value as your answer, right? And I know that you know that this over here does represent your y. So once you do this math, you get a y. When you plug in an x right here and right here, you get out of it a y. Let's look at composition of functions. Ready? Let's look at f of g of x. What if I wanted to find f of g of 2? So f of g of 2, you know what that would mean? That would mean take 2, plug it into g. What do you get? Don't give me the answer. What does it represent? Plug 2 as an x value into g. What do you get out of it? You get a y value out of it. You know what I want you to do with that y value? Your answer. I want you to take the answer, the y value that you got, and now I want you to plug that y value into f, where the x goes. So you're getting an answer out of g, and you're taking your answer from g, and you're plugging it into f. You're plugging a number into both functions. They're just different numbers. You're plugging, like, say, 2 into g, you're getting that answer and plugging it into f. It's pretty cool. So it says, using the graph on the front, let's do f composition g of 1, or in other words, this is the way I like to look at it, f of g of 1. Here's our plan. I want you to plug 1 into g on the front of your paper, that graph on the bottom right. You're going to look at the, what color did I make that? You're going to look at the purple function. Look at the purple function when x is 1, what's y? It's not that. When x is 1, hang on, I did something wrong. Let me look at it. When x is 1, here we go. Purple function. When x is 1, what's y? -5. Okay, so right here. Yep. When x is 1, y is -5 on my purple graph. Now let's take this answer of -5 and plug it in to f. Answer. Now I'm plugging it into f. So go to your yellow graph. -5. 1, 2, 3, 4, 5. When x is -5, y is +3. So I found g of 1, I got an answer for that, plugged it into f, and got an answer for that one. All right. Last one. You get to kind of like build your own composition of functions. So ultimately, ultimately, we want to look at h of x as 1 over 3x minus 8. But it said, you know where that came from? This came from taking some function called g and embedding it into f. What could they have been? What could I have taken as a function named g, embedded it into f, so that my result looks like this? Well, I think that maybe g of x could have been 3x minus 8. What would f of x had to be so that you take out the x and you plug in 3x minus 8? What would this have to have been so that you would take out the x and put 3x minus 8 in its place? I think it would have to look like that. Ready? So let's embed this function into this function. So remove this, put this in its place. Yep, that's what you get. Okay? Think about it for a minute. See if you can come up with another option. I think many of you can. And I think some of you are like thinking, oh gosh, how can I get that? I think it involves this. So, yeah, if gx is 3x, then x would have to be 1 over, let's see, think about this. I need to take out the x and put just that in its place. So this would have to be x minus 8. Okay, and then usually when we're all live and we're all in the classroom, I always get this smart aleck that raises their hand. They're like, I've got one. What if I made g of x just x, and I made f of x 3x minus 1 over 3x minus 8? My typical response is, oh, that is so lame. And the smart aleck says, but it works. Like, I can take this out and put that in. Okay, yes, you can. That's lame. Also, g of x, 1 over 3x minus 8. And this would just be x. That's lame. And it's so lame, I'm going to document it. Lame. Okay? Put some thought into it and give a possibility of what you think the two smaller functions could have been. That's it. That's a wrap.